and ant starts its journey from a point on the circumference of base diameter 60 mm and height 80 mm of cone and reaches the same point in a shortest path over the surface of the cone. Find the distance travelled by the ant and show the path of the journey. Here the nowhere is asking what to do here. A solid has been given, so that is a cone which having the base diameter of 60 mm and height 80 mm. The cone details has been given. So after that, so logically presented an application problem. So what it's given, an ant starts its journey from a point of the circumference of the base. That means on the course, at a particular point on the base, it starts and reaches the same point. So by making journey over the surface of the cone. So he is asking what is the shortest distance it travelled. So indirectly, whenever the solid problem you are finding in any way and asking any shortest related question, it is nothing but indirectly development of the surface. It's nowhere asking to develop a particular surface of the cone or you have to do something to develop the surface. But indirectly, logically, you have to understand anywhere, any question with respective solid. Keep in mind, not with respective points or lines or something, the planes. With respective solid, if it has been given any shortest length or wire or thread or something is asking, you are finding the shortest mean, indirectly you have to conclude in your mind, you are going to develop the surface to get the required solution. So now, indirectly, even it is not asking, so this is the problem of the development of surface only. So now before moving to the solution, remember the data for drawing the solution. So what the data? Solid requirement. So what are the solid details? It is a cone of base diameter 60 mm and height of 80 mm. So there is not sectioning or nothing has been given. A ant starts from a point on the base circumference and reaches again the same point. Is asking shortest distance travel, at the same time is asking the show the path of the journey in its projection. So let me draw the solution. So now since the first primary you have to draw the reference line. Since it has been given a cone, so you have to draw the cone with the given dimension. So what the diameter 60 mm. So take the 30 mm as the radius. Draw the primary circle first. Draw the circle to represent the top view. Whenever the resting condition is not given, you can understand the default position as the standing position. When the standing, the base must be in HP. So the top view I taken as our primary view. To make the visibility, I am just making the ink line. So after that, wherever you are getting the circle, you are just normally use it to divide into the 8 or 12. So let I want to divide 8 equal divisions. So let I divide into the 8 equal divisions. Draw the primary division as a horizontal line. Next, draw the perpendicular line. So after that, it has to be divided into 8. We need the 45 degrees radial line. So wherever you wish to draw the angular measurement, take the protractor and place it properly for its alignment. So then 45 degrees from one direction, 45 degrees from the other direction. So once you are granted the angular direction, take a scale and align the angular direction point with the center and draw a radial line. Similarly on the other side, along the angular direction, align the point with the center and draw the line. You are divided into the 8 number of equal divisions. After that, label them every point. Let A, B, C, D, E, F, G, H and apex will be O. Once you are completed the top view, so then move to the other side. Draw the projector from every reference of line here. Since I need the axis point has to be located, so for that I am taking the axis projector line. So now since the height has been given as a 80 mm, I can locate from the base distance apex point O dash at the A dash. Clear? At 80 mm your marked height. Next label them as A dash, B dash, C dash, D dash, E and F is invisible, here G is invisible, here H is invisible. So once you are completing with the normal scale, so complete complete the front view. We draw on the front view. So you can just draw the primary lines also. Generator lines can be represented here also with light lines. We represented the respective cone projection. Now here the question comes. Anyone guess so what could be the reason? There's so many answers in the practical. You will check this. Some students replied. So it is along the diameter. Along the diameter means suppose assume it starts its journey from here and over the circumference again it reaches there. The sum shows that it will moves up and comes down another direction. So but so many answers getting. So let me check how the intelligent ant can be. So ants always you can search any way the flow it will be try to move in shortest path. So now let me consider so how it will be done. So as I explained, so it is a part of the development of the surface. So before adding to the journey of the ant, so let it develop the surface. So with considering the cone itself. So whenever the cone given, you have to apply the radial line method. So for that you have to consider some calculation part. So that calculation part is nothing but sector angle formed by the developed surface. So for that one, so what the relation of formula we are saying, the theta equals to small r by capital R. We can calculate by using theta equals to small r by capital R into 360 degrees. So what the small r has been given 60 mm diameter mean it is of 30. Capital R is nothing but slant length to be measured. So multiply by 360 degrees. So let I check so how much the slant length is here. So for that one I can measure with the scale, otherwise we can confirm with the compass. Collect I am taking the distance from where I have to measure from apex to base corner. So this is a little precision measurement. I am getting it is around 86. I am getting the measurement of 86 mm. So that is the slant length. So here in our calculation, so what it could be taken 30 by it is of 86. So now let us consider how much the value can be. Take your simple calculator. Just let calculate the calculation. 30 divided by 86 multiplied by 360 degrees. So that equals to how much? It is of 125.6 degrees primarily I am getting. 126 degrees. So but normally whenever we are getting, we are making into the 8 divisions after that. Why? Because you have to take the calculation as a measurable with the protractor. So let me consider the same angle to be divided into the number of 8 divisions. So by that one how much I get it. So it is getting 15.7 degrees. 15.7 degrees. It is not possible to measure with our normal protractor. So that's why I make into the nearest rounded value of 16 degrees. So whenever it is a 16 degrees, so how much could be? If it is a 16, how much angle can be considered? It should be, I can approximate as 128 degrees. So now once your calculation, so then move to the next. Now I calculated the angle should be taken as 120 degrees. So what the radius to be considered? So this R. R is nothing but the slant length measured, true slant length measured. I can measure that one and I can use for calculation. So for that one, you can consider anywhere some point, a center of reference, that is O. We are applying the radial line method. That's what I can take the distance measured from here and this point as the center. I can draw one blind arc now. After that, take the scale and draw the primary, a simple normal line first. I am taking the simple primary normal line I am considering. So this is the O and this point I can consider as the A. So after that, so what is the included angle I am getting? It is equivalent to 128 degrees. So take the protractor, I can identify the 128 degrees and just I can fix the last one. Otherwise, if you are drawn that one, I have to subdivide into the remaining 8 equal parts. So that's why 128 by 8 is nothing but you are getting 16 degrees. I have to draw the each radial line at 16, 16, 16. So identification of the 16 degrees each time measured with the protractor a little bit some confuses. So any figure you are taking here and there, that radial line may not give the true shape. So for that one, take your utmost interest and identify the primary division radial line. So how much radial line I want to be? 16 degrees in this case. So that case, take the protractor here. Place the protractor properly aligned here. So once you are getting the proper alignment, so now measure the 16 degrees value. So this is the 16 degrees value. So along the 16 degrees radial line, first let you complete the first radial line. So for that one, I am taking with the help of the scale in the direction of radial division point. Clear? I am drawing a line. I drawn a line here. So once you are completed, this is nothing but next division point B. We know that each division must be same offset along the curved surface. So that automatically gives the true measurement. So now for that one, I will take the compass. Since this distance is span of 16 degrees, measure linearly this much. Now 8 divisions I need. So 1 over, this is the second one, next third one, fourth one, fifth one, sixth one, seventh one, and eighth. So like that, logically you have to proceed. So once the divisions are over, this is the C and D, E, F, G, H. Again this is the closing point A. So once I completed, so join all the radial lines. With the help of the scale I can proceed. I can just draw the radial line from every division segment to the apex OA. So now I am able to get all these points. So now after that, we know that the curvature at end we are having because we are not making any sectioning, the complete periphery will be in our consideration of the development. So I am drawing the development here. So now without considering anything, simply I developed the cone surface. So now coming to the problem situation. An ant starts its journey, let us assume at A, it started. It make around the cone and again it reaches there. If some students already I know, most of the students reply that it will be passes along the circumference. If it is did so, now consider. This is the A point. So where again it comes back at A only. Now A to A point, if it is moved along the circumference, so what the distance it has to be travel? This much distance it has to travel. He is asking and it travels, already proven it is shortest distance. So the shortest distance is nothing but a straight line. So inside the curved part, so now we want to find the shortest distance A to A. So what is the shortest distance? It is nothing but a straight line. Just we can connect by the straight line, measure the distance, so that will be the solution. He is not asked nowhere to develop, but we are relying on solution on the developed surface only. So now the development has been completed. So let I want to just calculate how much the shortest journey it travel. This is the A, starting point and ending point is same. So just I am connecting this as a straight line. So this distance is the answer. If we are saying that it is along the circumference, how much distance extra it has to be made. So now consider this is the solution. So one of the question is asked, the shortest journey it made. Okay, I can just conclude the answer here. Shortest distance it travelled is, you can now measure the length. It is 15.6 centimeters. That means 156 millimeters distance it has been travelled. Now what is asking? We want to show that path in the projections. That means it starting point unknown and ending point unknown. That means it will becomes again same point. If it is moved along the circumference, I could get A, B, C, D, E, F, G, H, I can join them. But it is not happens like that. When in the shortest journey, it covers the slant edge B somewhere, slant edge C somewhere, D somewhere. So that means wherever you are getting the slant edge alignment, you have to label them with specific points. Okay, let this is the A point. I can conclude this as the P. Let as a Q. This is the R, S, T, U, V. Again you can get into A. So now we can measure every distance will be transferred back. In almost all the some previous problems, some of the problems, we have transferred the distances from U to developed surface. So now you have to reverse it. From the developed surface, you have to move back. So that means the P is aligned on the slant edge of OB at the distance. But you have to consider one more thing. All these distances are the true distance, that is the actual distances. But whereas the OB is the slant length, you cannot get it as a true measurement. So that's why you have to transfer all these distances along the particular and the true length, and it has to be transferred back onto the original positions. So for that one, take the compass and measure the distance here. This O to P and O to V. Both are the same distances. I can just primarily transferring on primary edge. On the primary edge, first I will locate all the points, so then I will look after. So this point is nothing but P dash as well as V dash. This point is representing both the points. Similarly, I can locate here the point here Q. By geometry, Q as well as U both are the same. Transferring here primarily onto the every point on the true length only. After that, I will transfer onto the respective points. So this point is nothing but Q dash as well as U dash. So other set of the points are, by geometry, R and T both will be the same intervals. So let it transfer first along the true measurement. So these points are R dash and T dash. R dash and T dash. So leftover one more point is the S. The S is directly on the E. E already we know that. So since it is a true length, so directly I am transferring the point directly. This point is nothing but G. So it measures S point. So this point is nothing but S point. This is the S directly I am locating. Since it is directly OE is the true generator only. So after that you have to transfer back so everything onto the respective generators. So for that one I need to use mini drafter. Take the mini drafter. Once the alignment checked, it is properly. So now the P should be on which generator B. So where is the generator B? Here is the generator B. Next similarly you are getting on other, so which is on H, and B as well as on H. So where we are having the H? That common point here also. Next Q and U. So where is the Q and U? The Q is on C, U is on G. So it has to be common distance. It has to be transferred onto the respective generators. So next R and T. R is on T. Next T is on F. So F and D is the common. It has to be transferred onto the. So now we have to connect all the points. Since it is a curved surface, every point to point should be joined by the smooth curved line. So like that means here is the P and V. Here is the Q and U. Here is the R and T. Here is the S point. You have to join the points such that here is the starts from journey from A. It touches P, then moves to Q, Q to U, U to R, R to S. Again just exactly the behind R to S to T, T to U, U to V, again comes to A. So this is the path of the journey in its front view. So the same thing you have to show on the top view also. So for that one, the same thing, front view, top view is on always same line. So based on that concept, every point has to be transferred back. So that means the P and V has to be transferred onto the respective points. Here is the point. Next Q and U. Actually where is the Q and U? Q and U is on the C and G. So that's why being if I have drawn, it is merging along the line. So before that one, to avoid the confusion, I can label here. This point is P dash, V dash. This point is Q dash, U dash. This point is R dash, T dash. Now we can get easy idea here. P and V are the generators of OB and OH. So this point OB, OH. So on OB, which point we are having? P point. So this is the P point and behind point is V. Similarly, if Q and U. So what happens while drawing the Q and U? It is merging along the generator. In such case, I have to transfer the nearest true reference. From the true reference, it has to be transferred onto the respective temporary generator on OE. From the OA, it has to be get back onto the smooth position. So actual, this Q and U will be on the generator of OC and OG. If drawing the line, it is merging and coinciding along the slant edges. In such case, you cannot position properly. For that one, I have to transfer nearest parallel generator. So that is on OA. From OA, temporarily I am shifting onto OA, but it has to be positioned onto the OC and OG. So for that I am taking the compass, this distance as the radius, I am transferring back onto the respective generators. So by doing so, what are the points I am getting here? This point is Q, this point is U. So next other points can be transferred. The R and T. Where is R and T? D and F. So these points has to be transferred accordingly. So this point is the R, this point is the T. So next one more point we are having, so that is the S. S is on OE. So this is on, so this is R, this is T, this is S. So now it starts the journey from A and comes to P, Q, R, S, T, U, V. Again it comes to the A. So like this it travels. So this path, like the droplet you can show here. So this is the journey of the ant over the surface of a cone. So like this you have to obtain solution for the given problem. It seems as a simple question, but it involves the development of the surfaces. So that's why you have to keep in mind, wherever in any solid problem, ask the shortest journey or shortest length required to be measured. That is indirectly development of the surface. So now this is the length measured shortest. So which is the answer for the question asked. After that we are showing the same thing in projection, the path of the journey. Path of the journey of the ant is in front view. The path of the journey is in the top view. So this is the solution for the problem. So now you have to add the dimension to complete the solution. And the arrowhead and height given is 80 mm, draw the 80 mm and add the arrowhead here. The since diameter has been given 60 mm, draw the diameter 60 mm. So this is the solution for given problem. So one more thing, to draw here I need angle calculation. At the same time the slant length measured also better to represent. So that also you can proceed with the help of dimensioning part. Just add the arrowheads with proper proportion. Since measured is 86, write it is a 86 mm. So now the solution of the problem. So diameter of 60 mm and height 80 mm cone. Ant starts journey at A and it just moves over the surface of it and again it reaches. So to find the shorter distance, you have to develop the surface from A to A, draw the straight line, being the straight line itself is the shortest distance from point to point. So measure the distance is 156 mm. So for the problem asked, the journey made by the ant in shortest path is 156 mm. The path of the journey in the front view, path of the journey in the top view. So this is a solution for the problem that has been asked.